Hi, everybody, and welcome back. In this set of videos, we're going to talk about the law of sines. And the law of sines is very helpful, particularly when solving with triangles that are not right triangles. So let's look at that here. We're going to let A, B, and C be measures of the angles of the triangle, and lowercase a, b, and c will be the lengths of the sides opposite of these angles. And the law of sines gives us the following set of ratios. So basically you have the length of a side and then over the sine of the angle across from it. And all these ratios are going to be equal. And this is also true again for oblique triangles, and this is where it's most helpful. We have other techniques we can use for 90-degree triangles, although this would still work. But for oblique triangles where we don't have a 90-degree angle, this is really helpful. Here are two examples of oblique triangles. So one of two things could happen with an oblique triangle. Either all angles could be acute. So remember, acute means less than 90 degrees. Or what happens is one of your angles is obtuse, like this one right here, this large angle. Obtuse means more than 90 degrees. And then the other two angles are acute. Now, to solve an oblique triangle, it's the same definition of solving a triangle. It just means to find the lengths of all sides and also find all the angles. So the nice thing here with triangles is you also want to remember that your angles always add up to 180 degrees. That remains true for all kinds of triangles. So we're going to use that idea a lot here to help us. And then we're also going to use the law of sines to help us find, usually particularly missing sides is the most helpful, but we can also do it with angles as well. So let's see an example. And again, if you need to pause the video at any time to take down notes or to just go back and rewatch, feel free. So this is the first example here. And in that example, we're going to have one angle is 46 degrees, one is 63, and then one of the lengths is 56 inches. Now, the labeling is important. So remember, if you have a capital C and a lowercase c, those would be across from each other. So this length is across from that angle. And I'll just draw a quick picture here. All right, so for angle A, this is 46 degrees. Angle C is 63 degrees. And then I know the length of C, which is the one across from it, that is 56 inches. Now, when you have two angles, these are the best ones that are not the best, but they're the easiest ones to work with because you can find the other angle really easily. This is actually an example in this case of something where you have side, angle, angle. And you remember from other classes, there's different types of triangles. This one is side, angle, angle, because you have the side, an angle, and another angle. So that's what you're given. When you have two angles, again, it's a lot easier to work with because we can find the other angle quite quickly. And we can do that by remembering that all the angles in a triangle add to 180 degrees. So here, 46 degrees plus 63 degrees plus whatever angle B is would have to be 180 degrees. So we can go ahead and solve. We're going to start by adding these together. This gives me 109 degrees. And then I can subtract by 109 on both sides here. And I get my last angle is 71 degrees. So actually my picture isn't too bad. They're all acute angles because they're all less than 90. So I don't have an obtuse angle there. Otherwise, maybe I should redraw my picture. But this looks pretty good. So if you have acute angles, your triangle is going to look something similar to this. Now I do need to find the other sides here. I'm going to get a new piece of paper because I'm going to run out of room. But this is where I'm going to use my formula. So let me just rewrite the law of sines. Now, when you use a law of signs, we're not going to use all three at once. You just use two at a time. It just really shows you that, any of the ratios are fine to pair up together. But the thing is, you do want to have a complete pair. So when you figure out your formula, you need to make sure that at least one of the ratios is complete, meaning that you know the top and the bottom. So if I look at my example here, the only pair that is complete would be the C pair, right? Because I have the angle there, and then I also have the length. So in this case, I am going to use this part in my formula because I have that complete piece, and then I can use either one of the others to find A and B. So this is side B and this is side A. We need to find them both. So we're just going to do it one at a time. I'll find side A first. So again, I'm going to go ahead and set up my ratio. Doesn't matter the order, everything is equal. So here I'm going to start with C because again, I know everything for C. So I have 56 inches right underneath over the sine, and the angle there is 63 degrees. And that's going to equal A. I don't know A, but I do know my other angle. So sine of 46 degrees. Now to go ahead and solve, you do need to have at least 3 of the parts filled in, right? If I don't have at least 3, then I can't go ahead and use this formula. It would not be helpful. So I'm going to keep solving here. What I could do is multiply by sine of 46 degrees on both sides, and that will cancel it from the right. And that allows me to write my formula as 56 times the sine of 46 degrees all over the sine of 63 degrees. Now, these are angles that we are not familiar with, right? They're not common angles. And the problem does say to round. So you can go ahead and use your calculator here. I'll bring mine up and we'll do this one together on the calculator. You just want to be careful. So sometimes calculators get a little bit weird with order of operations. I'm going to just do my numerator first. 56 times sine of, actually, let me check my mode. See, make sure we're in degrees here. I just switched my mode. Let's try that again. Sine of 46 degrees. I'm going to hit enter on that. And then I'm going to go ahead and divide it by the sine of 63 degrees. And I have about 45.2107. And they want us to round to the nearest tenth here. So this will be about 45.2. And remember that our other unit was inches. So we're going to stick with the same units. All right, so I have one on my sides, and now I need to find the other side. It's better to not use rounded, oh, sorry, this would be B here, rounded values if you can. So again, you could use A over sine A now because I do have both of those values, but usually we try to stick with the ones that we don't round. So I'm going to start with the original because we know C as part of the original data. So I'm going to stick with that. So I have 56 over sine of 63 degrees, and this time it's B over sine. And then if I go back to my B angle, let's see, my B angle was 71. Oops, you can't see that, was 71. And again, I want B by itself. So what I can do is multiply by sine of 71 degrees on both sides. And then I have that B is equal to, let's see, 56 times the sine of 71 degrees. It doesn't matter which one you write first, just a little bit easier to read with the 56 first. Over sine of 63 degrees. And again, you're going to use your calculator here. I'll let you try that at home. And you get about 59.4 inches. So now we're done. We have all 3 angles, we have all 3 sides, and we have solved for this triangle. And this is the method you want to use if you have a side angle triangle. So if you have 2 angles, again, those are going to be your easiest ones because you can find your other angle very quickly using the 180 degrees. And then you can use the law of sines to find any missing lengths. All right, let's try another example here. All right, solve triangle ABC if A is equal to 50 degrees, C is equal to 33.5 degrees, and B is equal to 76. And again, we're going to round lengths to nearest tenth. Oh, sorry about that, guys. I'm doing a bad job trying to line up the camera today. There we go. So there's our question. So we're going to solve the triangle ABC. Sometimes we name triangles based on their angle names. A is going to be 50 degrees, C is going to be 33.5 degrees, and B is going to be 76. And we're going to do, it doesn't give us a units there, it just says 76. So why don't we choose units? Let's go with inches again. You could do something different. All right, so I'm going to start. You have 2 angles and one of the lengths. And actually, this is an angle, side angle triangle. So first, let me find the other angle. So if I took my 2 angles here, I see that, 50 degrees plus 33.5 degrees plus B is equal to 180. If I add these two together, I have 83.5 degrees. And then I subtract that from both sides. And again, you can, of course, use your calculator here. And you get about 96.5 degrees. So our last angle is over 90 degrees. It's an obtuse angle. So my triangle is going to look, let's see if I can, I don't know, try to draw it. So maybe it's like a little bigger there. And like this. So it's a little bit more than 90 degrees. So let's see, this could be angle A, B, C. So we have 50 degrees, we have 33.5 degrees, and then this is going to be our 96.5 degrees. Now, the other thing I know is I know the B value, which is right across, which was 76. I do not know the A, and I do not know the C. Now, this one is called angle side angle because the information you were given was an angle, then a side, then an angle. So that's where it comes from. It just lists them kind of in order, angle, side, angle. If you look at the last example we did, right, it gave us the 46, the 63, and the 56. So if you think about the order, you had a side, angle, angle. Oops, my goodness, I'm being bad with this. So if you look at the order, you had a side, then an angle, and then an angle that was given. So that's why you have the change in order. So side was first, angle, angle, whereas now what's happening is the side that's given is between the 2 angles. So we call it angle, side, angle. It really doesn't matter when solving for law of sines. If you have 2 angles, the process is the same. So I don't want you to stress too much about, the 2 different names here. It's helpful to recognize them, and you may have seen them before. But if you have 2 angles, the process is going to be the same. You can find the other angle first using the 180 degrees, and then we're going to use the law of sines to find the missing lengths. Now here, notice that I have all information for B. So my main ratio is going to be my B value over sine B. And then if I'm looking for side A, I'll do A over sine A. So again, remember, one of your ratios has to be complete. And the only complete one I have here is the B information. So I have 76 over sine of 96.5 degrees equals A over sine of 50 degrees. The process is going to be the same for solving. You're going to multiply by sine 50 degrees on both sides. So we have 76 times sine of 50 degrees over sine of 96.5 degrees. And remember, if there's no symbol in between, it's automatically multiplication. So again, you're just going to go ahead and use your calculator here. We can do this one together again. So I have 76 times sine of 50. And remember, just make sure you're in degree mode here. And then we're going to divide that by sine of 96.5. And I have about 58.59 would round to 6, so 58.6 degrees. Oops, what am I saying? Degrees here. Let's see, what were we doing for our units? Inches. There we go. So 58.6 inches, excuse me, we're doing lengths here. So our length is in, we just said inches in this case. All right, and we do need to find side C as well. So I'm going to start with my original ratio that I knew. So 76 over sine of 96.5 degrees. I don't know C, but I know the angle. So sine of 33.5 degrees. Again, I'm going to multiply by that sine of 33.5 degrees on both sides. I have C is equal to 76 times sine of 33.5 degrees, all over sine of 96.5 degrees. And again, I'll let you try this one at home. You're just going to go ahead and use your calculator and round, and you get about 42.2. And again, let me be careful here. We're doing length, so this is in inches in this case. You would just stick with whatever units the problem gives you. So if it's centimeters, stick with centimeters, inches, etc. So here we'll stick with inches. And that would be our final answer. So we have all three parts for the sides and then all three angles as well. So we have completely solved this triangle. And you just want to be careful with your labeling. The labeling actually is important here for the triangle because it does give a certain sense of order and what's across from each other. So that's just one thing to really kind of keep in mind as you're going